So here's my version of number five. It's pulled up and so let's see what we know. So I see that there's vertical asymptotes at x equals -1 and x equals -4. So I'm going to write those. Remember, we're taking x equals -1 and writing that a factor. So I'll bring the -1 over by adding it. And I'll put it in the denominator because I know I can't divide by x. I know x equals -1 is not in the domain of this function because it's a vertical asymptote. And the same thing with x equals -4. I'm going to write that as x plus 4. And then they're telling me across the x-axis at 2 and at -3. So again, I'm going to write those in the numerator because 0 over a number is 0. That's how I know it's an x-intercept. Um, so let's see what we got. I got x plus, no, x plus 3. Let's see here. X plus 3, because I got to bring the 3 over. And then x minus 2. And then what I see is I see they tell me the y-intercept. It'd be nice if they told me the horizontal asymptote, like they're going to do in number 6. If this were the problem, I could just stick the 7 there because this is going to become x squared over x squared. And that's because it's the same degree. I could just plug it in. Now, I mean, I can just take the horizontal asymptote, and that's my A. Now, here they just tell me a y-intercept. So what I need to do for this one, then I'm going to think, okay, I know y equals 7 when x equals 0. So 0 plus 3 times 0 minus 2 over 0 plus 1 times 0 plus 4. And if I do some arithmetic here, I'm going to get, what, -6. So A times -6 over +4. And of course, I like to simplify fractions if I can, if it's not hard. So that's going to become -3 over 2. And I'm going to rewrite it so it's in front of the A. So that means I'm going to divide by -3 over 2, which is the same as multiplying by -2 over 3. And so nothing cancels out there. So I know A is going to be -14 over 3. So there's a couple of ways to write this to make my math happy. You could stick a -14 over 3 in front and do that. My math would like that. What I usually do with when I'm giving something like this, it's not an integer, I'll put the -14 on top and the 3 on the bottom, and that's what my open math is looking for. Okay, much easier when they give us the horizontal asymptote and it's the same degree. Okay, so hopefully that helps. The only one I'm doing making this video, I'm going to point out one other thing, even though you didn't ask about it. Because people, this is if they're going to make a mistake with in this section, this is the mistake they're going to make. You see the difference between um, question number 8 and question number 9? Do you see how in question number 9 the graph heads in the same direction at around that vertical asymptote of x equals 3 while it doesn't up here? So this tells me down here, this is going to act like at that vertical asymptote, it's acting like 1 over x squared. So when you write this out, you're going to have to do x plus 2 for the 1 over here. And then when you do the x for the 1 for x equals 3, you're going to write x minus 3, and then you can remember to square it. Okay. That's what, whereas here, I don't have to do that, right? Here, I could just say x plus 1, and then x minus 4, because those are acting like 1 over x here and acting like 1 over x here. Remember those toolkit functions from way back in section, what was it, section 2, I think? Maybe it was section 1, 1, 1, 1, 2. So those never go away. They're always with us. Okay, I'll stop this video and give me a yell if you need more.